All right, guys. So as I was just saying, now when we look at these two binomial expressions, what you notice here in the factor form, because these are the factors. So one factor would be a plus b times the other factor, which is what? A minus b. When we multiply a plus b times a minus b and simplify the middle term, all that we have remaining is a squared minus b squared. And so that would have given us this as the result. So in other words, if we expand these two binomials, it means that these are factors, but when we multiply them out, the product would result in this expression. So the expression from multiplying out these two factors would be a squared minus b squared. Go ahead, Ms. Wilson.
Sir, how you got one of the bracket to be a plus b and one a minus b?
Well, actually, it's not that we actually got them to be, is that it so happened that when we are given those factors to multiply,
oh, we get that.
we,
Okay,
end up with this product. So,
okay.
So the factors are just, if you want to say, happen to work out to be a difference of square, these two factors. So because these two factors, when we multiply them, we get a difference of square. What we are saying now, if we should get the product and reverse it from the product, because this is a product that we get, and this is the expanded form. And so if you reverse the expanded form, you should go back to the factorized form. Now, what would be the factorized form? The factorized form would be simply what? A plus b times a minus b. So if you're given this product, a squared minus b squared, if you factorize it, what you should get? A plus b times a minus b. Now, because this is pretty much straightforward, we just tend to try to memorize the fact that if we have a difference of square and we factorize it, we get back this. So with that said, we are now going to think of this in a sense of a formula. So whenever we see difference of square, we are going to treat it as a formula, and the formula would be a squared minus b squared. Once you get a difference of square, when you factorize it, you would get what? A plus b times a minus b. Now, to look deeper at this formula, if we look at the brackets, all we're doing here is to factorize a difference of square. We simply open the two brackets. We simply take the base of the first and the base of the last and put in the two brackets. So we put the A here, we put the B here. We put the A here, and we put the B here. So we put the bases in the bracket. That means we put them in without the powers. And then now all we have to do is to remember that one is a plus and one is a minus. And that's all there is to it. Any question? Is it clear how to factorize difference of square, guys? Let me see your hands. All right. So, all right, so let us see now if you are actually following what this is saying. So this is a general formula, and the formula is written with A and B. That's capital A and B. But when you get an expression, you're not going to see A and B, but instead you will see values in either algebraic form, such as this. All right. When you look at the ignore the right-hand side of the equation. Ignore this for a little bit, and let's look at the left-hand side. Now, this is the expression that you're given. Now, just as how we would have tried to identify the expression to see if it's a perfect square, we also need to be able to identify a difference of square. Now, difference of square just simply mean we have one square term minus another square term. And once we identify that, then it means that we use the formula. All right, so how do we identify that we have a difference of square? Same way as how we look at the perfect square. Look at the number in front, the first term. Now look at the letters first. The letters are squares. Then you look at the numbers in front of them. Can those numbers be written in squared form? So of course we have the 3. We have 3 squared would be the same as 9. So of course 9 can be written as 3 squared. So if 9 is the same as 3 squared, we can write this as 3 squared. And 16 can be written as 4 squared. So it means that once we write it like this, our aim is to ensure that we can clearly see that the first term is a square term, and we can clearly see that the last term is also a square term. So if we put if we put the square terms of the all the squares of the first term in brackets, then we have 3a squared, and all the squares of the last term in brackets, the bases, then we would have minus 4x all squared. And clearly now we can say, yes, we have a difference of square because we have one square term minus another square term. Now the other step now would be to factorize them. And to factorize these, what did I say we need to do, guys? Let me see if anybody was following me.
Write back the base, sir. So we don't have
before we do that, just open 2 brackets, please. Open 2 brackets, put them beside each other like so. Everybody following? Then now, Miss Wilson, what we do?
Sir, write the base in the base.
The bases.
And put them in each bracket.
And put both of them in each bracket. So we put 3 in this bracket. And then we put 4x as the second term in the bracket. We're going to put 3a in the second bracket again. And then we put 4x as the last term in that bracket too as well. And all that we're going to do next is Miss Wilson.
We're going to add a positive sign to one side and a negative sign to the other.
So just put a plus sign in one and a minus sign in the other, and it finished. Just like. Let me see the hands of those who understand that. All right, so that's just how we factorize difference of square, because we're using the formula. What is the formula again? A squared minus b squared is the same as what? A plus b times a minus b. So that's what we would have gotten when we factorize this. Now, look at this one though. You think you'll be able to factorize this? Let us see whether or not you can give me an answer for this without me walking you through it. What will be the answer for this? Give you about a minute to figure it out, and then you tell me what the answer is. Anybody come up with the answer yet? The first question you want to ask yourself here, do we have a difference of square? Can you identify a difference of square here, students? Yes or no? Ms. Clark.
Sir?
Do we have a difference of square?
I guess so, sir.
If you're guessing, it means that you're not sure. I don't want you to be guessing. I want you to be sure. Miss Cabrera, do we have a difference of square?
I do not know.
All right. Sometimes you just need to look carefully at the expression and see if you have a square term minus another square term. Let me find out. Mr. Ojeno, do we have a difference of square?
Yes, sir.
Why you say that?
Because you have C square and you have A minus B brackets 4. So that would have two similar two square in it, sir.
All right. Anybody else agree with Ojena? Let me see your hand. All right, Mr. Campbell is in agreement. Anybody else? All right. It so happened that I am also in agreement with Mr. Ojena. Yes, we have 2 square. Not because we have this as a bracket doesn't mean that it is not a square term. Remember I said to you that when we are treating things in bracket as a group, we can also think of it as a single unit. So this bracketed expression is considered as a single square unit. And so we can have this bracket as a square unit minus the C as another square unit. And so if we are going to use a formula, what would we do here? Let's weigh some. What I say I must do first? Ms. Clark, what are we supposed to do?
Sir, I'm not sure.
Well, no,
Are you going to have like A square minus B square minus C square?
You see, clearly you're not sure. That's
Exactly, sir.
all right. So if you just think of what I've said, procedural wise. Now, I would have already declared that this is a difference of square. So if it is a difference of square, when we're using the formula, what we generally do, we have to open 2 brackets. That's the first thing you want to do. Now, once you already identify you have a difference of 2 square, you open 2 brackets. What are you going to do next? Miss Clark, what are you going to do next? I'm not Miss Clark, man.
Sir, I'm not sure.
Please, some help us out. It can't be that hard. We're doing the same thing as we have been doing. What are we going to do? Put the two square terms in the bracket. What are the two square terms? The first one is the bracketed expression square. So that is a minus b squared. So we put that in the bracket as a square term. What is the next square term? C. We put that in the bracket as a square term. And we put the same 2 over here in the other bracket. A minus b as a square term. And then we have what? Now, I write this to show you that we're actually using the base. We're really not using the square, but I'm just showing you that these are the square terms. So if we are putting the bases of these square term in the bracket, that means we are going to write them without the power. So it means that this wouldn't have a 2 here, and this wouldn't have a 2 here, and this wouldn't have a 2 there. Everybody can see that now? How we get that? Everybody see that? Raise your hand if you're seeing what I'm saying, guys.
Sir, why does the C doesn't have a square?
Because remember, if you look at the one above here, when we're factorizing difference of square, we don't put in the formula, when we factorize it, is the base that we put in the bracket, not the entire bracket with the square. If you look at this term, Miss Caveira, is the base. All right, look up here. You notice these is actually the base we put in the brackets, you know, the base, meaning that we put them without what? Without the square. So when we're factorizing, we take the base of the square terms and put them in brackets. So if you think about these terms, the base of this one would be just this without the 2. The base of this one would be the C without the power 2. So you put them in without the powers. And then now you put what? One as a plus and one as a minus. And that's all there is to it. It seems weird. It seems kind of tricky, but that's what it is. You're just following that principle. That's a rule for difference of square. And if you are, let us just go back to the formula itself to show you that that's what the formula did. See there, this is a formula. So if you have the first term square and the last term square, we take the 2 terms without the squares, put them in the brackets, in both brackets. So we take the base of A, base of B, put them in the brackets, and then we give one a plus and we give the other one a minus. That's all there is to it. So if we are factorizing these, we first write them in the square form. Then we put the base of each of these square form in 2 brackets. Then we put a plus and a minus between them. And likewise with this, we put the brackets in here, and we put a plus C, then we put a minus C, and then that's what we end up with. Any questions? Students?
Sir, I just need to practice more.
Yeah, well, that part I know, but I just want to see whether or not you understand the procedure of what we're doing. If we are using the formula, this is the procedure. It might look weird based on the expression, but you're not focusing so much on the weirdness, but the procedure. Because if you have a square term minus another square term, The procedure is that you put the base of each of these square terms in two brackets, then you put a plus sign between them, and you put a minus sign between them. All right? And so you would have seen that from here, we take the base of this, the base would be what? A minus B for the first term, then we put in the C. So that would be, we could write that as a plus C. And then we take the A minus B again. And then now we have a minus C. Now, if we simplify this further, when we say that if you have a bracket without an obvious number in front of it, the number would be +1. So if you multiply out this distributively by 1, all you're left with is the A minus B in the bracket, and these two in a bracket would have disappeared. And that's how we end up where we are down here. Let me see the hands of those who understand what is happening, but like Ms. Cabrera, need some practice. All right, so it's just a matter of just practicing the procedure in order to kind of be comfortable with it. All right. All right, now what I will do, I'm going to stop here. Now, we're going to come back to this, both the perfect square and difference of square. I'm going to come back to them on Thursday because I know that it's a little shaky in your heads now. Some of you don't really fully grasp and appreciate it yet. But Thursday, I'm just going to review it, and then now we can do some practice afterwards. All right? So just take a little while to digest this now. And then on Thursday, we look back at these two types of expression and practice how to factorize them. All right, guys? So we are going to be ending here. Now, just for those who are probably still working on the SBs, reminder that the time is near for them, for those. So just send them to the address that I have posted in the groups. All right, guys.